Swayam Prabha. Digital India. Educated India.
Okay, so very good morning. My name is Prasad. I am a professor in the Department of Chemistry, IIT Madras. I joined here 2006, long back, and my lab is actually next to this room. Next is two labs are mine. We work on light matter interaction. So the topic that we are going to discuss today is also something related to that. Light matter interaction. So that's a common topic name that we can refer. Many things you already learned about light matter interaction. Can you tell some of the things that can happen when light falls on matter? Photoelectric effects that you learned. Okay. What else? You can see because why we are seeing objects? What is the phenomena happening? Light get reflected. So reflection is the phenomenon. Then what else? Refraction, dispersion, okay, scattering, refraction. One more is the refraction and similar word, diffraction. Yes. Then light scattering. Diffraction, yeah, diffraction. What else? Interference, yeah, interference can also happen when two waves. So when we are talking about light when falls on matter, as a result also after reflection then interference is possible. One particular thing you did not mention. Absorption somebody told. Polarization doesn't have to be connected with absorption. After the matter absorbs the energy from the light, excitation happens, then emission. Whatever the absorbed light, it goes to the excited state, or the matter will get more energy from the light, then that energy has to be released, right? So eventually it will emit the light, and that is we call fluorescence. Sometimes we call phosphorescence. There are different names. These are all light emitting events. So many light matter interaction phenomena are there. Absorption, emission, refraction, diffraction, right? Reflection. So among them, one thing that we are going to discuss today is absorption. So I have some worksheet with me. I will hand over to you. Okay. What I want you to do is attempt it individually first. Okay. Then after a few minutes, you can have a discussion, see what your partner is also doing along with your line or something differently. But first don't discuss. Do it yourself. Okay. I am here. If you have any doubt, you can ask me. I will help you. This is not an exam or anything, but there are two. See how many are there? Can you distribute this? I hope everybody will have one sheet. If not, we will share it. How many are there? 2. One more is there, no? Yeah. Sorry. Thank you. How many needs more? Just start doing individually. One more is needed. Yeah, this one. So I think they put exactly the same number. Okay, fine. So in a minute or so, you just finish 2 pages. I hopefully. So if you have 2 pages, then we have a break now. But ensure that minimum 2 pages are done. Okay, so we will stop now. What I want you to do now is each table, suppose 4 people are sitting, you pair up 2, 2. If 3 people are sitting, 3 of them can discuss, but first person read the answer to the next person and hear what answer the next person is writing. So next 5 minutes is just talk to each other and then see the answers that you are providing to page number 1 and 2. This one. You exchange it and then see what is the answer. P? No. So the first question you are talking about, and you are writing like that. You are asking, what is your opinion?
If there is no absorption, that means if the light source which goes through the sample emits all the light it absorbs, means P is equal to.
So you are putting so many ifs there. If it emits, but we don't know, right? What they are saying is it's only absorbing. Emission part they are not even mentioning. So in that situation, suppose you have a sample and light falls, pass through it, it absorbs light. Now what will happen to the intensity? That's the situation. So what will be the so that's what you are. I think they are also getting the same. Whenever there are two different answers, you discuss about that. Everything is fine. 2 pages.
Sir, by 2 pages we refer to this one also.
I mean, we go stage by stage, but 2 pages. 2 pages. Everybody is
Yes, sir.
on the same page. Okay. Okay. Good. Then you can proceed further.
Yes.
So first 2 pages are okay. Same answer. Identical answer. Okay. Now you proceed to the next one. Individually you do. After doing, discuss. Okay. Any discrepancy, any difference of opinion? First
Got
2
the
pages.
same things actually.
You all three got same.
Yeah.
If yes, proceed to the third page. If there's a difference in the answers, then I need to see that. All of you are getting the same answer, then proceed to the next page.
I don't know. How do you translate? What do you mean?
So that's what you discuss and then see is there any difference. Come. So first 2 pages, did you?
Yes, we have doubt on this.
What is that?
So, transmittance is directly proportional or directly proportional? Sir? If it absorbs more, it can transmit more. There is a large.
Transmittance is what? Whatever coming out.
Yes, sir.
So if something is absorbing, then transmittance will be less only, no?
If it is absorbing more from the light rays source, so this will be more. So
This will
transmittance
be
will also be proportionally
no.
a little more, right?
It will be less only, no? Transmittance means what? Light coming out.
But
You-
as
you-
a race, like good absorber is a good emitter or like transmitter.
No, don't worry about emission. Emission, we are not even talking about anything. Okay? Transmission is not emission. That is where the confusion probably happens. Transmitted means something is passing through. Okay? So this is like 100 people are coming. Some people are staying here, some people are going up. So if it is more people stay here, less number only come out.
Yeah.
Okay? Any other question, doubts? All right, here.
How is this? How is transmitted? What is the correct answer?
How is the
How is transmitted and absorption?
connected? What do you think?
First when I saw the question, I thought it's going to be directly proportional.
Okay.
Then I got confused that if an object absorbs most of the light, then it won't transmit it 100% to it. It will reduce like for sunlight will actually the plants will get only 10% of the sunlight and give it to that cyclic mode. So I got confused.
So let us try to understand what the terminology means. Absorption is something the molecule is taking the energy of the light. Transmittance is no interaction with the system here. The light is just passing through. So more absorption will lead to less transmittance or more transmittance. Less transmittance, because more is taken, remaining only come out. Okay, that is the answer. So in the first 2 pages, if there are discrepancies between you, please raise your hand. I will come and then discuss. How about the table? All are same page, no problem. And proceed to the next page. What is the issue?
Sir, I would like to know the difference between transmittance and emission.
Okay, there are 2 different phenomena. I think many students are there, so we are going to make a common point here. Transmittance means just passing through. Emission means first absorption, then emission.
So, absorption and emission are the ones which are like directly related.
Everything is related, but there are different phenomena. Transmittance is not emission.
So, basically, some light is coming and it absorbs some light, and the
Remaining
light
will
is the
transmit it.
So, that is transmitted.
That is transmission.
Emission is the one that is absorbed.
Whatever absorbed comes out is emission.
Which is completely or partially emitted.
Yeah.
Can we say that transmission is inversely proportional to absorbance?
That's what this question is. No. Second question, they are asking what is the relation.
So the more it absorbs, less.
Less only it will transmit. Exactly. That is the relation. Okay. So here all are okay for the first 2 pages. Then go to the next page. Here, any confusion? The first 2 page, everything is absorption, transmittance, relation. What is the relation?
So it will be the inverse to what we
Inversely related, right? Good.
P can be equal to P naught, like lesser than or equal to equal or not.
If there is, what is that? If there is absorption,
So it will be always less.
Should we take this one as the initial and divide it by this for everything, or this one would be
this is the initial 100, no?
so
This is the initial.
So we just divide.
Ah.
So then log we'll get negative values after a point, right? So how do we plot?
They're putting negative log.
So if we take negative log, these two I get positive. After that it becomes negative.
Log 3 is negative. What is log 3? You can use
log of 1 by 16 also.
log of.
1 by 16.
What is the value coming from? This is transmittance value. Where is the transmittance value?
So these values. So P1 is 50 by 100 is 1 by 2, 1 by 4. So,
Okay, so first you take the log of that and then negative.
so log of 8 into S power minus log 3 into 0.9 minus 1.
That is negative, no? So then negative of that one. They are plotting negative log.
After that point it becomes.
After a part you are getting negative.
Yes, sir.
Let us see. You just try to find out that we will compare it. After doing, discuss. Okay, don't discuss and do. First you individually try, then you discuss.
Log to find values.
You calculate anything is there. Cell, or you don't have a cell phone. Phone is there? I use it. Why not? That's what I think they took only exact number. I saw that there are 36 students, so they gave 36 copies. Even I don't have a copy. I wish I had. Maybe after this. No, I can send you the. Okay.
So, in this graph, for each of these solutions, for example, this solution, will the P be 25 and the P naught be 50, or the P naught will stay constant and be 100 for each and every case?
So they are saying P naught is the initial one.
Yes, sir.
For this, incoming light is P1, not P naught.
Yes, sir.
So it is 50.
So this will be different.
Okay, sir. So here it will be constant for everything. Like, is it 0.5 for all of them?
No, transmittance will be different, no, because incoming light is different.
Yes, sir. But this is the light being transmitted, and this is the incoming light.
So every time absorption is happening, right?
Yes, sir. But every time it will be 1/2, right, sir? 12.5
Okay.
by 25.
Okay, every time is 1/2 is given.
Yes, sir. 50% of the light is
Right.
transmitted.
So 1/2 of the incoming. So the value may be different.
Yes, sir. But the transmittance will be the same, right, sir? So
That
here
is
they have
the
asked-
ratio.
Yes, sir.
Yeah.
So
Transmittance
here
will be.
will the graph be like 1, and for this one will be 0.5 and will be constant?
No, that is not possible. No?
It will go decrease and exponentially.
Yeah. So what way it will decrease is the question. So you are saying P by P0. P0 is constant, but P will be keep on changing.
Okay, sir. So P0 is constant. We have to take 100 as P0.
Because P0 is 100 only.
Okay, sir.
Right.
So, but P0 is the incoming light. For this sample, the incoming light will be only 50.
Oh, okay. You are asking about that way. No, but the equation is P by P0. So P0 is the values which is this 100%.
Okay, sir.
That way it has to value. Transmittance will be changing.
Okay, sir.
We are defining transmittant with respect to the initial source.
Okay, sir.
Okay, so P0 is constant, P will be changing, so T will be changing.
Okay, sir.
Maybe like something like that. Yes.
Excuse me. So for this graph, after we finished it, we found the values of transmittance and following exponential decay. So my question is, when we go to this page, they're asking us to do minus log 10 of t. How do we calculate that for like 0.5?
You just put log T first, then take the negative of that.
So I don't memorize the values of this.
Oh, you have a calculator. I mean, oh, no, obviously, you need a system. I mean, like.
So we can use our phones
Yeah, obvious.
And any like decimal place requirements, what would you recommend to like get a linear graph?
2 decimal place is good enough, just to give the trench.
Okay. Thank you.
What you have to do in this space?
I don't know. You figure it out.
You have to write the same 50% only.
See, what is T? Transmittance, right? Transmittance is P by P0. What is P0?
P0, 100.
Every time P changes,
So we have to write,
what are those ratios? That's called transmittance, right?
yes sir, this values only we have to take.
Ratio, P by P0.
Okay, for this values.
Huh.
I got this for this.
Each
question value.
time, what is P by P0 will. Okay, so can you pause for a minute, all of you? So we start with a simple diagram where there is a light source coming from and falling on a sample, and the light is passing through the sample. So many students have this confusion. When the light is passing through, this is called transmittance light, and light is getting absorbed, whether the transmittance is as a result of the emission process. So many students ask me, the transmittance means the light is absorbing and then emitting, and that light is getting coming out. Answer is no. Okay, transmittance means light just passing through a medium without any interaction. There is no light matter interaction. That's called transmittance. So absorbed light will not be transmitted because it is absorbed, right? So the difference between the intensity of the falling light and the outgoing light, there will be always a difference as long as there is an absorption. So that's a part that initially they are discussing about. And the relation between absorption and transmittance is inversely proportional. The more absorption, less transmittance. Okay, that part is clear, right? And now you go to the third page where a series of absorption events happens and you are asked to calculate the transmittance on each one and then plot it. So once you complete the plot, let me know. We'll compare the plots. Okay, yeah, exponentially decreasing, right? Okay, this is this one. All right. So intercept is 0. Okay. Yeah, it's basically y is equal to ms plot.
Yes.
Yes, tell me.
We figured out it's linear, but we don't know how to plot this exactly.
Why? What is the confusion? You have locality value? I mean, you need a system. Calculator is there, no?
We can use this.
Yes, it's not an exam. It's only a learning exercise. You can use calculator, okay? Nobody is going to prohibit you to use calculator or internet or anything. Or move around, systems are there. Feel free. Otherwise, how do you calculate locality? You cannot memorize. You are stuck somewhere? Okay, going good now? After plotting the graphs, we need to compare. And then answer those two questions. Once you plot, then answer these two questions. Great. Other plot? And this one? 0. Good, 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 good. Then proceed next page.
Yeah, it's negative.
2 plots. Okay, great. And this one? Okay. Now it is easy once you plot this. Good. Yeah, now move to the next page. If you plot the 2 graphs, you move it. Once others complete, we'll pause for a minute in between. Any issues?
Actually, I'm having quite confused out.
Okay, what is the confusion?
Yeah, so first, let's say we are taking a series of samples and the solution, any of the samples are light absorbing.
Right.
So if you put through a light, if you shine light, it is going to absorb certain light and the remaining it will be transferred or transmitted.
Transmitter.
Now they are putting in containers that do not absorb it. So either
They are putting?
the containers that the solution are do not absorb light. So
No, it containers are not absorbing.
the containers.
Sample is absorbing.
Yeah, the containers do not absorb. So it should either transmit or totally reflect.
No. The only, I think this bracket only that they want to tell you that only sample is absorbing. Containers are not. Containers made of aluminum, copper, or glass. I mean, not so, like something transparent only. So glass, quartz, those things will not absorb the light. Otherwise, your analysis will be wrong. If your sample is absorbing, container wall also absorb means, then your everything calculation will be wrong. That's why they're giving us a condition. But good point, I will tell it to everybody because many people may not understood it properly. Okay, so can we take another moment? Please stop all the exercise. Attention here. Everybody stop what you are doing. So in the third page, I just read the sentence and ask you what did you understand by this. Suppose that we have multiple identical samples of a light absorption solution in bracket in containers that do not absorb light, and we set up them in a line with a light source with power P0 shining down the line from one end as shown in the figure 3. Now, what does that bracket means? In containers that do not absorb light. So what do you understand by that clause? Transmission? Transmission fully occurs. How do you interpret that bracket thing? How do you understand that? Sample is absorbing, container is not absorbing. How did you interpret that bracket? Okay, what is your take on that? Did you see that bracket thing or you just neglect it? Okay, that's also possible, huh? Transmitter is 1. Transmitter 1 means P by P0 is 1. P by P0 is 50%. Container, yes. Container transmittance is 1. Okay, okay. Why are they mentioning that one? So, how do you interpret that? Did you see that statement?
When you calculate, you can take the light, you can take transmission as half continuously because the container doesn't absorb anything.
Okay, okay. See, so why they are specifically saying containers are not absorbing light? Because in light matter interaction, one of the issues or experimental condition or kind of criteria is the container should be transparent. Otherwise, light will not come out. Transmittance will not happen. So, transparent means what are the transparent materials? Glass, quartz. So, some of these things we can use it to make the container. That can also absorb light, no? Some frequency of the light that material can absorb. If that absorb, then whatever the transmittance that you are measuring may not be equal to the sample absorption. So we need to mention or we need to be careful that your container is not absorbing when you study the light matter interaction with any matter. That's why they are telling that. Okay, that is one point. And everybody get a exponentially decreasing plot for the first figure 4. Figure 5, everybody got, oh, okay, you are still working on it, okay. Yeah. Figure 5, everybody got a increasing straight line passing through origin. So slope of that one, the intercept is, they are asking what is the value of the intercept? 0. Okay, move to the page number, next page number 5, I think. This part is clear, no? You did not write it, but
I don't know.
no, you don't have any confusion, right?
Yeah.
Okay. Any confusion about the plot? Okay. Okay.
Question one, I can understand that as absorption increases, distance equality decreases.
Right.
But I'm not able to find out if it's a linear relation or.
That is what you said, here.
Yes, but that was related to number of particles. But this is distance. Right?
Same thing. That's what they are saying. If you read it carefully, they are basically putting this figure. Just imagine you are just clubbing it. Instead of 6 different things, they are putting 6 lines. So the same distance is light is traveling.
But okay, so whether they're there or not, the distance does not. I mean, whether they space differently or not, if they are
Light,
together, the distance
how
does
much
not.
time the light travels through the sample?
Okay, so sir, I'll just tell you, I'm not clear. So, for example, we place 6 different containers. The distance it travels from from here to after the 6th container is still the same if the same container has all the 6 different.
Exactly. Now, don't count this distance between the containers.
Okay.
Light traveling through the sample. That is the distance that we are measuring. Okay, so that is why this total distance and this total distance may look different.
Yes.
But if you say that how much distance is light travels through the sample, that is the distance.
But as it is a solution, so we have any type of container.
Is this right at least?
Change. Yes. And that will affect the absorbance or transmittance.
Based on that, the absorption will change, the distance will change.
Now, if the container distance changes, absorption will change.
Yeah, so, but the distance remains constant.
No, distance also changes. Because the container increase means what? Light has to travel more.
Yeah, so greater absorption. Okay, then how will we determine this? It's based on the container, right? How can we bring a proper relationship? How do we know how the container
if we say
have a standard size?
So we have not standard size. Only thing is we have the relation as the proportional relation. One is increasing, other one is also increasing.
But here we are only talking about the number of containers. We do not know the size of it or not.
No, that number of container is here. That number of container, now they are saying that that will be equal to the width of this one container. If you can imagine that there are slices.
Okay, so the container will be just as big as all of this.
Exactly.
Okay.
That is the imagination that they are asking you to have.
I thought they were somehow string together.
And no, we are just imagine that whatever the distance individually, now they are connecting it. So now it passes through it. The total distance will be equivalent to the other one, previous one.
One second help.
For example, if the player in the line, the distance will be greater. solutions are put together.
How do I write it in terms of T proportion?
Despite the same volume.
I know. So don't imagine that way. The only thing that they want to tell is you just take the linear distance of each one. So some like 0.1 millimeter or whatever it is. Now imagine that the same distance is shown by this each slice. Okay, it's only linear distance, like diameter or that way. Even if it's cylindrical, just take the diameter of that, and then you just add it up. Volume is no. Volume will be same. It's not about the volume. It's about the distance, linear distance the light travels through it.
But I'm just telling, but still if you're going to take that container and transfer everything, that volume will be greater to bring the same height as something.
Volume doesn't matter. Even if the height changes doesn't matter because it is uniform. Okay. So light absorption is not going to be affected by that.
So this is only valid for n number of containers of a particular diameter or something, and this should be the summation of all the diameters.
Essentially, what they want to tell you is that the length affects absorption, which is proportional. It's a basic learning. Okay.
So based on the thing that I've understood, and the distance of the absorption should be same.
So it will be increase.
Why?
Because you plot this way, this absorbance, this is distance. You are telling it is increasing.
I'm thinking is, since you take these slices, light passes through, certain amount is absorbed, certain is transmitted.
No, there's no transmittance here. Transmittance is only after this.
It absorbs certain, it should transmit it so that the other.
When you say absorb and absorption is happening here, whatever the light not absorbed is transmitted. Okay.
Still, as it is the same solution, the amount of absorbed amount of light should be the same.
Same to?
Same for each slice because it is the same solution.
Right. So that means, so each slice will absorb a particular amount, remaining will transmit. Now imagine more slice. What will happen to the transmittance? Many slices are there. So absorbance will increase or decrease?
How the distance is.
No. Okay. Alright, so one confusion here. Question figure number 6. Right? They are saying that there is a container which is absorbing light and there are several slices. Slicing is essentially to tell you that you can imagine any container with partition of equal amount species present in there, or we can say that the length of the previous experiment, whatever you have seen in the previous experiment where they put individual cells, now they are combining it and putting in one cell. This is to tell you that light is traveling essentially the same distance of the previous experiment, linear distance. In that case, they are asking what will be the relation between absorption and the length of the cell. N stands for the length. So when N increases, you have already plotted, N increases, absorption will increase. This N is called path length. The length through which the light is passing through the medium. That is the path length. So when path length increases, absorption increases. Suppose you have a container with 10 slices or 20 slices like this. What will happen to the absorption corresponding to this? It will be more or less. So many students are getting the value that it will be the same. How do you get that idea? No, distance will increase because I am increasing the. So when I say slice number increase means each slice I am keeping constant. So the container size will increase. So what will happen to the absorption? It will increase. Because, see, essentially, use the common sense. The sample is getting more time for absorption, right? Because the light has to travel through this. Your path length is increasing means there is an opportunity for the sample to absorb light. So obviously absorption will increase. So the relation that you are going to get from question number 9 or 10 is A is directly proportional to N or L or whatever that symbol that you are going to use for the distance. So the learning that you are getting is absorption is proportional, absorbance, not absorption. Absorbance A is proportional to length, path length. Okay, proceed. Now you have a confusion? Clear? Okay.
If absorbance is directly proportional to path length, compared to the 6 separate containers and compared to this container, the amount of transmittance will remain the same for both.
Because essentially they want to say that imagine that 6 cell, now you club it. The linear distance of each cell, if you are representing in one cell, same situation. So transmitter will be the same.
If there was a container, in this, transmittance will be greater than 6 separate containers that would also absorb light.
Say it again.
If the medium of the container was not one that would not affect the absorbance of light, but rather one that would also absorb light, the container.
Container absorb is a problem. I think any of these days container is not absorbing.
Oh, if the container were to absorb, here there will be more transmitters than 6 separate.
No. So normally what we do is, we in all experiment we make sure that container will not absorb. Container absorption will not be, we don't even need to consider it because that will complicate the entire process. Only sample absorb. Okay. So individually you are taking 6, now you are clubbing it in one, same phenomena, same situation. So the same transmitter you are going to get. What they want to realize you that when this container distance increases, essentially more absorption chances are there, probability is there. So absorbance will be more. That is the idea. Okay. Now go to the next page. Let us see whether we can. I think we don't have time to. So now we may not complete it today. We are going to have one more class. We'll continue there. But right now take 2 minutes. Each team make 3 bullet points about the learning that happened in this 1 hour. Whatever that you learned, make 3 bullet points together. Quickly.
Am I right about this? That as a concentration increases absorption.
Same thing, yeah.
So
So now this is the equation coming. Yes.
Depends on what kind of substance they add on it, right, sir? It's like they're probably adding invisible
So this part we'll discuss in the next class. Okay, you keep that page, but right now you just complete this length. Now this is the situation. C and all coming here. This is next page, no? This we'll discuss separate. Next class. My name, Prasad. Okay. Alright. So now quickly summarize your learning in 3 bullet points. Then I will ask you to read it. N is the distance. Right. Containers, they look same, no? So that every container will have same diameter. So they are comparing the same. See there, this is an analogy basically. Like with these individually taking or together taking, distance travel will be the same. And then if absorbance is proportional to the distance, here also you will get the same phenomena. Suppose I take a bigger container, more absorption.
So we take a simpler solution, simpler case, and we solve it so that we can obtain a generalized.
Yeah, that is the approach.
The other thing is, what is the difference between absorbance and absorption?
Absorption is a phenomena. Absorbance is defined as minus log T. Okay, minus log T means log I0 by I. Log T is P0 or I0, P by P0, right? That's why the definition. So minus log T means
Yeah, this is the highest.
log P0 by P. So absorbance is ratio of the intensity, logarithmic value of the ratio of the intensities. That's called absorbance. Okay. All right. So let us hear from each team. One learning from your team. You just tell whatever the Only one, eh?
Absorption is inversely proportional to transmittance.
Absorption is inversely proportional to transmittance. Okay, another one.
The number of identical solutions that a certain ray of light passes through is inversely proportional to the transmittance.
Say it again.
The number of identical solutions that a ray of light passes through is inversely proportional to the total transmittance.
Okay, number of.
Yeah, the number of solutions.
All right, fine.
So transmittance and emittance is different.
Very good. That is one learning. Yes.
So observance increases if the length increases or the concentration increases.
Okay, very good. You said what? Can you repeat it?
Observance increases if the length or the concentration increases.
So use the word absorbance. They use absorption. They are different thing. Okay, in science terminologies, terms are very, very crucial. Absorbance is minus log T. Okay, absorption is a phenomena. Yeah, whatever learning you had. Quick. Whatever you learned.
The path length which the light travels, it is directly proportional to the absorbance.
Absorbance, very good.
We understood how absorbance and transmission are related with one another.
Okay.
The concentration is directly proportional to the absorbance.
Very good.
What we realized was in figure 7, like unlike other figures, we were not given any data to say that concentration is directly proportional to absorbance. So what we initially logically assumed was concentration may be inversely proportional to transmittance instead. And the equation we got was A is equal to some constant into B plus some other constant into B log C. But then I turned to the next page and it says it is directly proportional to absorbance. So what we realized was sometimes something may be logically right but may not be the experimental result.
So I mean, learning happens in iterations. Sometimes we have a particular way of understanding things, but the more information comes, you need to change accordingly. That is the learning. Good. From your table.
I don't know if this is already said, but absorbance is linearly related to concentration and path length. Is that right?
Concentration part, I think many other teams did not reach there, but
Okay.
it's also there in that.
We notice the exponential decay in the transmittance as the number of slices increases.
Transmittance decreases. Okay.
Yeah, the exponential decay.
Yeah. Exponentially. Okay. All right. You already did, no? Yes. Okay. So good. We had a nice interaction. You learned something. We'll continue this in one more session sometime in the in this. I think you have 1 month here, right? So we'll meet again. Okay. Until then,